Hi everyone, my name is Gareth Jones. I'm an RSc Research Software Engineer here at the University of Bristol. I'm part of the School of Chemistry and the ACRC, and I work on the OpenGHG platform, which is a platform for greenhouse gas data analysis, which hopes to be an open platform for sharing of data and performing analysis on atmospheric gas data. This is a NERC-funded project, and I work on it with Dr. Rachel Tunnicliffe from the School of Chemistry, Professor Matt Rigby, and Dr. Crystal Woods, who's head of RSc here at the university. So OpenGHG hopes to be a platform that brings together data from lots of different sensor networks. So these are sensors that are on different sites across the UK, North America, the Caribbean, and South Korea. So, for example, this is a map of the DEC network, which is a sensor network of tall tower sites. So these are big towers run by different companies that are for radio transmissions and etc. And these have sensors based at the site, and these take in gases from different heights at the along the height of the tower, and this can tell the scientists a lot of different information about what different gases are present at the different heights in the atmosphere. And all this data is often in very different formats, different calibration scales, lots of metadata and things attached to it, but it's often stored on servers in the lab that people just have access to within that group, and sharing it between groups and things. It can often mean uploading things like a zip file to Dropbox, which isn't great. So we want to build a platform, or we're building a platform that will facilitate the sharing of this kind of data and performing analysis. And so we've set up OpenGHG, which can do processing of these different formats. So we often get formats in lots of different ways, and you'll have three formats that make sense, and then the format which is like another format but it's changed because, say, the postdoc that's working on it hasn't quite filled in the right information or has deleted part of the header, and this makes the processing scripts a bit fiddly. So we standardize all these different data formats and store them. So we make sure that all the metadata is associated with them is stored and all that type of thing, and then we make them available through a Jupyter notebook interface. So we run a Jupyter Hub, and anyone that's familiar with things like in the Python ecosystem will hopefully have used Jupyter Notebooks or may have used Jupyter Notebooks, and these are very nice for doing analysis of data, doing little plots, maybe running some simple simulations, and then we can make this available to different users around the world. So we can give them a login account and they can access the Jupyter Hub and run Jupyter Notebooks, set up simulations, pull down data from different sources, upload their data, and make sure all this type of data is standardized and available. And then all this data is open. When users and data providers give the information, they'll tell us how much information or how much data they want to make available, and we obviously try and make them or get them to make as much of the data completely open as possible. So recently there was the COP Summit in Glasgow, and we used our platform to bring in data from different sensor networks across Glasgow. So there's Beacon, that's based in the University of Berkeley in the States, the University of Cambridge, and a company called AQ Mesh. And there's also the National Physical Laboratory. They had some sensors up in Glasgow. And yeah, this was all for the UN Climate Change Conference 2021, so COP26. So this is an example of one of the sensors. So this is an AQ Mesh sensor that was distributed across Glasgow. And here you can see a small map of the different sensors. So there was quite a few different sensors from the MPL group, University of Cambridge, Beacon, and the AQ Mesh. So a range of different sensors of different types, so very expensive high-grade sensors in different parts, and then some of the cheaper but also very, very useful sensors stationed around Glasgow. So this allowed information to be pulled in near real time and put up on our dashboard. So we have a range of sensors distributed across Glasgow. We've got data coming in, being processed by OpenGHG, and some functions in the cloud. So these functions are just things you post data to them, it gets processed, and then it gets uploaded to GitHub. So all the data is available on GitHub, which I'll show in a few minutes. Data comes in every few hours or so, it's processed in the cloud, stored on GitHub, available on our dashboard, and all data is public, CC by SA4. And this is a short video of the dashboard. So you can see here the dashboard has a plot of the carbon dioxide at the site. So this is Glasgow Science Centre Tower. You can select methane and CO2 data. So there's a range of sensors across Glasgow you can see, and we can move around the map, zoom in, have a look, and we can select, let's select here St Thomas Secondary School. So here you can see this is a part of the Beacon network. So we can have a look at the different data. So data's come in up until very recently. So today is the 28th of March, and we can zoom in on this data and have a look and see how it compares. So you can see the different spikes and things of the carbon dioxide, and we can see that the data is still being processed. It's coming in from the different sites. So here we have the sensor network across Glasgow, and also a mobile methane study. So this was a researcher from Royal Holloway, University of London, that drove around Glasgow and found a large methane spike coming from near the Ibrox Stadium. So yeah, this is just a little plot of the methane spike that the researcher found in Glasgow. We also have a little explainer, so showing different emissions. So this is trying to make data explain the data really, and show that it doesn't need to be complex, and just give a little bit of a background of the kind of work that people do, so people can hopefully interpret the data more readily. And here we just have showing how the different models are used, and how this data is processed, so how the scientists themselves use this data. So this is just a little simulation of how the data is processed. So the dashboard's available online. This is released under the Apache 2 license. This is just JavaScript. It's all open source. I've tried to document it, hopefully as well as I can, and little installation so people can run it themselves, have a play around. And then this is the dashboard data. So this is automatically uploaded every few hours. It's the CC by SA4 license, so people can just pull it down and have a look. So all the information's there, all the data's there, and people can just pull it down and do whatever they like with it. Thank you very much.